So the reason why we're jumping to chapter 5 is because we just finished chapter 2, which was solving equations. And solving inequalities is the same exact thing as solving equations. There's only one slight difference, that if you multiply or divide by a negative, you have to flip the inequality symbol. But anyways, before getting to the actual notes, let's just go through some real examples here. So we have this sign, and you have to be at least 18 years old to operate the equipment. What does that mean? You guys can't do it. I mean, unless you're 18 years old, right? It does mean that you have to be 18 or older to operate the equipment. So what does that mean in terms of on a number line on a graph? Well, we have a number line right here. And since we're talking about 18 years old being the magic number to be able to operate, I want to put 18 in the middle. Then I'm going to fill in the rest. So according to this sign, you have to be 18 years or older. What does that mean? Could you be 15? Absolutely not. 18? Yes, you could be 18. Could you be 19? Yes. 20? Yes. So on a number line, what we're going to do is we want to represent all the numbers that are 18 or older. So what we do is put a solid dot and an arrow going this way. That represents the inequality of the sign above. And we're going to put a solid dot, not an open dot. Now, what is the difference between a solid dot and an open dot? The solid dot means that you're including the number. An open dot means that you wouldn't include the number. Right? Okay, perfect. So if you say 18 and above, then you're going to put a solid dot because it's including 18. But if it says you have to be older than 18, right? That means above 18. You can't be 18. You have to be older than 18. That would be 19 and above, right? Let's go through some other examples. But before moving on, you guys have to understand this. If you're including the number, you must put a solid dot. If the number's not included, then you must put an open dot. And notice that on purpose, I put the period with an open dot right there. Okay. Anyhow. And one more thing that we should do after graphing it is to actually state the inequality. So this one, I mean, in terms of x, let's just say x. X is greater than or equal to 18, okay? Let's take a look at the next example. You want to go to Disneyland? You want to be able to get on all the rides? What does this sign say about that? And what is that certain height? 42 inches, right? 42 inches. So, and you know, you have to be able to interpret the signs. Just because it says that a person has to be 42 inches tall, I'm way taller than 42 inches. Does that mean I can't get on it? No, right? I mean, there are actually some that have a height max or weight max. But in this case, they're just talking about you have to be at least 42 inches tall to get on the ride, okay? So on a number line, we're talking about the magic number 42, and then 43, 44, 45. And we're talking about inches, 41, 40, 39. So, am I going to put a solid dot at 42 or an open dot at 42? You have to be 42 inches or taller. Solid, right? Solid dot. And if it's taller, is it going to the left or to the right? To the right. Or as I like to say, to the right. Okay? Now, what do I mean by that? See, anything that's on the left side is going to be less. Anything that's on the right side is going to be greater. Okay? Yeah, I use a right instead of right. So anything on the right side is going to be greater. Anything on the left side is going to be less, right? So less, left, less, right, greater. And this inequality here, we're talking about height requirement. Let's use a variable h. H has to be greater than or equal to 42, right? So when there's a solid dot, you're including the number. That means that it could be equal to 42. In other words, you have to put that underlined equal to on the inequality. H is greater than or equal to 42. Right here we have anybody interested in going to the Army? Yeah? Well, even if I wanted to, I cannot go to the Army. So as we could see right here on this webpage, it says in order for you to join the Army, you have to be 35 years or younger. You can't be older than 35. So I could not go to the Army even if I wanted to. So let's say I wanted to represent that as an inequality, what would I write? Well, your age has to be what?
35.
Or less. So your age has to be less than or equal to 35. That's a good inequality right there.
So your last number is going to be 35?
Yeah. So if they ask you to graph it, you're just going to do a quick number line. Just put the number 35 somewhere in the middle. Now you can do a couple more values, 36, 37, 38, 39. Going backwards would be 34, 33, 32, 31. And this is going to be a solid dot because it has a solid line underneath the inequality. Okay, so I want to put a solid dot down there. And it's going to the left because that's less than. So we might be a little rusty on this from elementary school, right? The inequality is always going to open up to the greater value. It's kind of like the alligator or the Pac-Man. So I don't even know if you guys remember Pac-Man. It's a really old video game. But this guy always wants to eat, right? So he always wants to eat the greater value. So we have the Pac-Man right here. And in this case, it's opening up to the x. So what does that mean? That he wants to eat the x. That means that x is greater than 5, okay? So let's look at the number line. I just put the numbers there. It says greater than 5. It doesn't say greater than or equal to. So if you're talking about something that's greater than 5, you're talking about 5, 6, 7, 8, 9, or 10. But you cannot include 5, so it has to be an open dot. Okay, it has to be an open dot. And it's greater than, and greater than is always to the right. So that's how you graph x is greater than 5. Okay. Now, number 2, what does that say? Bernardo. Let me help you out there. Check it out. What does that say? In terms of, is x bigger or is negative 2 bigger? Negative 2 is bigger, right? It's opening up to the negative 2. So the question is, what does this say in terms of x? It says x is what? If negative 2 is bigger, that means x is less than or equal to negative 2. Okay, so x is less than or equal to negative 2. So let's put the numbers on the number line. So it's kind of confusing when you put the values that are negative, because going this way, they're getting more negative, which means they're getting smaller. And going this way, they go towards the 0 and towards the positive, which are getting greater. It's always less than going to the left. It's always greater than going to the right. Anyhow, we said that it's opening up to the negative 2, so negative 2 is greater. That means that x is less than or equal to negative 2. So is it going to be a solid dot or open dot? Solid dot at negative 2. And is it going to the left or to the right? To the left, because it says less than, so you draw an arrow to the left. The next one, x is what? Paul, help me out here on the next one. X is what?
Greater than or equal to negative 8.
Thank you very much. Greater than or equal to negative 8. So I'm skipping every other number, so it doesn't look that ugly. Is it going to be an open dot or a solid dot at negative 8? Solid. Why is it solid? Because there's a solid line underneath the inequality. Okay, so if there's a solid line underneath the inequality, you're going to put a solid dot. If there's no solid line underneath the inequality, it's going to be an open dot. Please jot that down. I should have asked you to do it before. Solid line underneath the inequality means you do a solid dot. Okay, so if it has a solid line, you do make a solid dot. If it does not have a solid line, you leave it an open dot. That's exactly like the notes before. If you are including the number, it's going to be a solid dot. If you're not including the number, it's going to be an open dot. So Chris, how about number 3? What does that say? X is greater than or equal to negative 8, right? It's opening up to the x. That means that x is greater. Pac-Man's always going to eat the greater value. So x is greater than or equal to negative 8. So is it going to be a solid line, or solid dot, or an open dot right here? Solid. Chris, why is it a solid dot? Because of the equal, right? The or equal to. Solid line underneath means you're going to do a solid dot. Okay, so it is a solid line, so you're going to put a solid dot right there. Now, greater than, is it to the left or to the right? To the right. There you go. And the last one, this one could be a little confusing. We always want to talk about x. We always want to represent x. So x is what compared to 4? X is less than 4. Now, if you read it this way, the way we normally read from a sentence from left to right, this says 4 is greater than x because it's opening up to the 4, right? But you always want to represent x, so x is less than 4. So the thing that I would do is I would take this entire inequality and just get the whole thing and flip it, right? It's kind of like if you you cut this out and you were to lift it up. If you were to lift this up and then flip it all around, you would end up with x on this side, the 4 on that side, but you have to keep the same respect. Now, what do I mean by that? If it's opening up to the 4, that means 4 is greater than, so 4 has to stay greater than x. So it has to open up to the 4. So that also flips right there. Does that make sense to everybody? Yes?
Yes.
Okay, so let's graph it. And let's put a solid dot or an open dot at 4. Open dot at 4. And that says x is what compared to 4? Less than or greater than? When we actually do the variable on the left, it says x is less than 4. So less than is to the left or to the right? To the left. There we go. So it'd be a good idea to get your variable on the left side. If you do get the variable on the left side, some students do this. Some students see this inequality and they envision an arrow, and that kind of helps them graph. So for example, x is less than 4. They look at that and they kind of, let me do this. Check this out. They kind of see the inequality as it being an arrow telling you to go that way to the left. Does that make sense?
Yeah.
Okay. Now that does not work if you have your x on the right side. That doesn't work. Okay. You can't use the arrow concept. You can't say, oh, it's going that way. That's incorrect. In order for you to use this arrow concept, you need to have the variable on the left side and the number on the right side. So if you look at number 1, I mean, what I do is I say, oh, x is greater than 5. Greater than is to the right. That's why it's an open dot going to the right. Okay. But if you want to use the arrow concept, go for it. We look at the inequality as an arrow, and it's telling us to go that way. So that's why it went this way. If we look at number 2, I know that it says x is less than or equal to -2, but you could envision it as an arrow that's telling you to go that way. So that's why it's a solid dot and going to the left. So you could use the arrow concept if you want, as long as you make sure that the x is on the left side. Okay? So that's why I took this whole thing and I flipped it. X on this side, 4 on that side, flip the inequality. Because you need x on the left side. So right here on the last one, yeah, it looks like an arrow going to the left, and that's why it's an arrow pointing to the left. I don't actually use the arrow concept. I actually just think x is less than 4, less than is to the left, greater than is to the right. So solving an inequality is almost exactly the same as solving an equation, okay? The only difference is if you multiply or divide by a negative, you must change the inequality symbol. So this does need to go in your notes. Please copy this down. So let's say you had this example, -2x is less than 8. Go ahead and copy that down. How do we solve this inequality? It's the same exact thing as solving an equation. Same goal. You want to get x by itself on one side. How would I get rid of this -2 right in front of the x? You divide, right? It's being multiplied by x, so you need to do the opposite of multiplying. You'd have to divide by -2. What you do to one side, you do to the other side. Divide by -2. And the -2 cancels. X. Now notice, if it were an equal sign, I would just write x equals -4. But this is an inequality. And the only difference between an inequality and an equation when you're solving is if you multiply or divide by a negative, you must change the inequality symbol. So what did I just do right here? I divided by a -2. So what does that mean? What's going to happen to that inequality symbol?
Greater.
It has to change the greater than. And there's my final answer. X is greater than -4. Okay, so you solve it exactly the same as solving equations. That's why we jump from chapter 2 to chapter 5. We just got done solving equations. We should be good at solving equations. And we might as well throw in inequalities because it's done exactly the same way. The only difference is when you multiply or divide by a negative, you have to flip the inequality symbol. Now, in addition to solving it, right there we solved it. Now we need to do a quick number line. And you guys, it's as easy as this. Draw a line, put the -4 right in the middle. Maybe fill in a couple more. And as you go to the left, it gets less, which means more negative, if that makes sense. And is this going to be a solid line or a open dot? A solid dot or open dot? Open dot. So let's put an open dot at -4. And is it going to the left or to the right? To the right. Why is that? Because x is greater than -4. Greater, right. Less, left. Right? So if it's a greater than symbol, it's going to be going to the right. Another thing that students like to do, visually, they see this arrow, kind of like if it were an arrow, right? So you could envision an arrow telling you to go that way, okay? As opposed to, so if it were the other one, it would be telling you to go that way. So some students like to do the visual, like to think of it visually. They look at which way the inequality is pointing, and they consider that to be like an arrow telling you to go that way. You could do that as long as you have your variable on the left side. Okay, so you got to make sure your variable is on the left side. So right here you see that it's pointing to the right, because that is a greater than symbol. It's going to the right. So you're going to go arrow that way, and that's how you graph. So solving, exactly the same. The only difference is at the very end, you get your answer. The only difference is that when you multiply or divide by a negative, you must flip the inequality symbol. And then, of course, we graph our answers on a number line. How about this one right here? Let's say I told you to solve 2x minus 7 is less than -11. So you're going to solve it the same exact way. What would your first step be, Ivy? Plus 7, right? You want to get rid of the 2 and the 7. Okay, so we're going to get rid of the -7 by doing the opposite, plus 7. And what you do to one side, you do to the other side. So we're going to go plus 7 over here. That'll cancel. You're going to have 2x is less than negative what? -4. For my final step, what do? Divide by 2. Divide by 2. Now again, what's the only difference between solving equations and solving inequalities? If you multiply or divide by a negative, you must change the inequality symbol. Did I multiply by a negative? Did I divide by a negative? I did not. I divided by 2. That's not -2, right? So I am not going to flip anything. It's going to stay exactly the same. X is less than -2. Yeah, you ended up with a negative on your answer, but you don't flip it because you didn't divide by a negative. Again, what we need, the only notes for today, these are the important only notes right here. If you multiply or divide by a negative, you must change the inequality symbol. Right here, I added 7. I didn't multiply or divide by a negative. Even if I were to subtract 7, I'm still not multiplying or dividing by a negative. Right here on my last step, I divided by 2. I didn't divide by a -2, so I don't flip it. And of course, we need to graph it on a number line. So let's put -2 in the middle, -1 that way, -3 this way. And which, is it going to be an open dot or solid dot? Open. And is it going to be going to the left or to the right? To the left. If you're visual, then you could see it pointing that way. So you're going to be, that would be your answer right there. To the left, right? X is less than -2. Less than is to the left, greater than is to the right. And in a nutshell, that's it. That's all we're doing for this whole chapter 5, sections 1, 2, and 3. This is what we're doing. We're solving exactly the same way. Of course, there's going to be more complicated inequalities, kind of like the ones that you have to simplify using distributed property and combining like terms. But it's all done exactly the same way as the equations. The only difference is that if you multiply or divide by a negative, you have to flip that inequality symbol.